Hi, I'm Anna Buckle. This is Graham Jones, and we're here at the Time and Date studio in Norway. And we're looking at a partial lunar eclipse tonight. And we've already been looking at a beautiful image here from the moon over San Diego, California.
Right. Tonight we have a very, very deep partial lunar eclipse. We're going to be here for the next 4 hours, and we can see right now that the edge of the moon there is getting darker and darker. Over the next few hours, the Earth's dark umbral shadow will cover 99.1% of the face of the moon. It is a very, very deep partial lunar eclipse, almost a total lunar eclipse. And the really unique thing about tonight's eclipse is its length.
Yeah, it's long.
It's a long one, right? So the very early stages of this eclipse started just over an hour ago. The entire event runs through until 12:03 UTC. That means the overall duration of this lunar eclipse is 6 hours.
2 minutes.
6 hours and 2 minutes. Right.
It's long.
That is long. For a lunar eclipse that is only a partial lunar eclipse, so for a lunar eclipse that doesn't have any total phases, that is extraordinarily long. In fact, the last time we had a partial lunar eclipse that lasted for more than 6 hours, it was the 14th century. And the next time it will happen, it'll be the 27th century. So tonight's eclipse is a once in 1,200 years event.
Once in a lifetime, really.
By almost any lifetime, that is once in a lifetime.
And who can actually see this eclipse, Graham?
Right. So we are looking here at a full moon, and this is a beautiful full moon we're seeing from San Diego in Southern California. This picture's coming courtesy of the San Diego Astronomy Association. So it's a full moon, and a full moon is visible from anywhere on the nighttime side of the Earth. And right now, well, we have our moonlight world map that shows the position of the sun and the moon right now. So at the moment, the sun is directly above the Indian Ocean. The moon is just above the west coast of Mexico. It's sort of over the next few hours, it will be moving out into the Pacific. It will be passing over Hawaii. So the nighttime side of the Earth right now is the Pacific Ocean and North and South America. Later on, as the Earth spins over the course of the next few hours, then Australia, Eastern Asia will see the moon rise in the east. But yes, right now, North America, South America, weather permitting, they have a great view of the moon.
Wow. This is very exciting, and we've made sure that we've got some great streaming partners from this area to help us show you guys the eclipse. We've been looking at San Diego here, but we've also got some other feeds for you in on the Big Island in Hawaii. We have 3 feeds. We've got the Starry Nights that are streaming from Waimea. We've got someone called Project Panoptes on Mauna Loa. They're going to be bringing us some images of the lunar eclipse. And we've also got the Subaru telescope, which is on the top of Mauna Kea on the Big Island in Hawaii. Moving along to the west coast, this is what we're looking at right now in Southern California. The San Diego Astronomy Association are giving us 2 feeds from San Diego, California, above the marine layer. They're quite high up them as well. And moving east into Ontario in Canada, we've got 2 streaming locations, 2 cities. In Sudbury, we have the Royal Astronomical Society of Canada Sudbury Centre. I managed to say that, at the Science North Museum. They gathered there together, and we're getting in 3 feeds from them,
Hmm.
hopefully. And 120 kilometers east of that in North Bay, we have the North Bay Astronomy Club that will be sending us a couple of feeds from there, 3 feeds from there as well,
Right.
right? Yeah. And finally, on the East Coast in New York, we have the Amateur Astronomers Association. They're streaming from a rooftop in Queens, New York. And we're crossing our fingers for clouds clearing and for being able to bring you all these beautiful streams that we've been working so hard with our partners to get.
Exactly. Yeah. At the moment, we've got this beautiful moon in San Diego. The current news in Northern Ontario and New York is they're fighting the clouds there, but we've got our fingers crossed that the clouds are going to be breaking later on during the eclipse. We're going to be here for the next 4 hours. One more thing we want to mention straight up front. On the left side of our screen, we have the timeline for this eclipse. Anna, what's the timeline all about?
The timeline is just telling us what stage we are at in the eclipse. So as you can see, we've been moving through the penumbral phase of this eclipse, and that's the Earth's lighter outer shadow. And it looks like, in about, I'm looking at the clock here, we're not far away. We're like 6-7 minutes away from where the partial starts, and we can almost see, well, we can't even almost see, we can see the dark shadow already. Earth's in a darker shadow is umbra moving across the face of the moon there, and that's going to be lasting, that period's going to be lasting. You're better at head math than me, but it'll be from 7:18 to 10:47 with a maximum eclipse at approximately 9:02. Well, it's exact time, but we're not going to see like boom, it's max. And so by the end of partial, the moon's going to look fairly normal again, and we'll be moving through the timeline like that.
Exactly, yes. So over the next few hours, that dark shadow we can see will be slowly moving across the moon, covering 99% of the moon's face. We're going to be bringing you live pictures of the entire partial phase here on Time and Date.
Yeah, and we're going to be back in a few minutes to tell you about lunar eclipses, why they happen, but make sure you go and check our live news feed. And there we've got blog posts about our partners, about what happens during lunar eclipses. You can share your pictures and you can ask questions. So go there, check us out, timeanddate.live, and we will be back soon.
You're watching a partial lunar eclipse on time and date. And the partial phase of this eclipse has just started in the last few minutes. We can see on the screen right now, we can see that dark shadow of the Earth starting to move across the face of the moon. Over the next few hours, 99% of the moon's face will be covered by that dark shadow. This moon picture on the screen right now, this is coming courtesy of the San Diego Astronomy Association. This is Dave Decker and Gary Hawkins. They are outside of San Diego. They're up in the hills. They're in a large parking lot on the side of a highway leading to Mount Laguna Observatory, and yeah, we're getting a beautiful image.
They were hoping to get above the clouds, and they've managed that.
They certainly have, yes. So yes, great moon image coming from outside San Diego. Anna, there was somebody you wanted to say hi to.
Yeah, I want to say hi to Luke. Luke keeps emailing us before we have eclipse shows. He's 13. He wants to be an astronomer and when he grows up, and he's convinced his parents to let him stay up and watch this eclipse. So, hi, Luke. Nice to see you again.
Okay, so a partial lunar eclipse. What exactly is that? Anna, can you tell us what exactly is happening in the sky tonight?
Well, this is like you were saying. This is a partial lunar eclipse. That's almost a total lunar eclipse. I think that needs to be said. Like we're going to see a lot in this show here. But first, a partial lunar eclipse happens when the sun, the Earth, and the Moon line up, and the Earth casts its shadow on the Moon. And first, we've been going through the penumbral phase here. That's what Earth's outer lighter shadow that's been moving across the Moon, and now we're moving into the darker inner shadow of Earth, which is called the umbra, and that's where we can see it's already eating across there. And actually, it's not really. It looks like the shadow's eating across from our point of view, but actually, it's the Moon orbiting into Earth's darker shadow there. And what happens is that right now we're looking at it and it's getting darker and darker, but the Moon does not disappear. As you can see from that diagram, we've coloured that umbra red. And that is because we've got something special happening during a lunar eclipse compared to a solar eclipse. Because during a solar eclipse, the Moon, the new Moon, comes in front of the sun and blocks out the sun's rays entirely. That's actually the only time we can see the sun's corona that we normally can't see at all. Because the Moon doesn't have any atmosphere. So it just kind of looks like the Moon has eaten a black hole into the sun. But during a lunar eclipse, Earth has an atmosphere. So the light from the sun hits Earth's atmosphere. We can look at a diagram there, and the blue light particles coming from the sun get scattered away, while the red light particles are bent during a process called refraction, and they hit the Moon and they turn the Moon red. And this is why we have red sunrises and sunsets, and this is why the sky is blue.
Okay. Now, just one thing, Anna. I mean, looking at that diagram in the corner of the screen, the Earth's dark umbral shadow looks really red in our graphic in the corner of the screen. If we look at the actual Moon that we're seeing from San Diego, the partial phase started about 10 minutes ago. So a little bit of that corner, that sort of top right corner of the Moon, is covered by the Earth's dark umbral shadow, but we're not seeing any red on our image from San Diego. So what's going on there?
Well, it actually is red, but it's really difficult to see because the bright part of the Moon is so bright that it kind of, I want to say overshadows, but it doesn't. It brightens over the uneclipsed lit part of the Moon. Is so bright that it takes away the redness. So as we are moving through the eclipse, as we're nearing this 99%, we're hoping to see that the Moon will turn red here on our feed.
Okay, so we are going to see a red full moon tonight.
A blood moon, I hope.
A blood moon. Okay. Stay with us on Time and Date. We're here for the next few hours covering the entire partial phase of this lunar eclipse. Also, don't forget to go to timeanddate.live, we have heaps of information there about the moon, about this eclipse. We have a live news feed with pictures coming in from around the world. That's all at timeanddate.live. And Anna and I will be back with you shortly.
Hey, welcome back. We're here streaming this partial lunar eclipse, or rather an almost total lunar eclipse. We're, well, according to our timeline, we're going to be hanging around in the partial stage for a bit more, but that shadow's really eating into the moon there, or the moon is orbiting into Earth's shadow, and we'll be reaching max. That will be like 99% of the moon covered at 1 hour, in 1 hour and 20 minutes. And we're still looking at this beautiful moon, courtesy of the San Diego Astronomy Association in Southern California. And they're just providing us with awesome images here.
Yes. And thanks to San Diego at the moment, we've been keeping an eye on the feeds we're getting in from elsewhere across North America. And in Northern Ontario, at our streaming locations in Sudbury and North Bay, we have seen one or two glimpses of the moon through the clouds, but they are still battling away against the clouds there. And in New York, again, sky covered by clouds at the moment. But again, we're really hoping that something will be possible later on during the partial phase. But at the moment, Ontario and New York, busy fighting the clouds.
Yeah, and it is busy. We know all about that. It's hard work. It's even more hard work when the clouds are there than when they're not, because they have to check and they have to refocus, and they're doing a great job.
They sure are. Yeah. Yes.
But you're going to tell us a little bit about why this eclipse is so long, because we mentioned that at the start. 6 hours and 2 minutes, and why?
Right. Yes. I mean, yeah, if we go back and have another look at our timeline on the left-hand side of the screen. So, right, the early stage of this eclipse started at 6:02 UTC. The entire event finishes at 12:03 UTC. It's 6 hours and 2 minutes. And this is only a partial eclipse. There is no total phase. There is no moment when the moon is completely within the Earth's dark umbral shadow. And that does make this unusually long. If we go back 6 months on time and date, we covered a total lunar eclipse that happened in May this year. Now, that was a total lunar eclipse. It was a deeper eclipse than tonight's, but there the overall duration was about 5 hours. So a total eclipse lasted for 1 hour less than tonight's partial eclipse, a deeper eclipse, but it was over much more quickly. And that does seem it doesn't seem like that makes sense.
No, it's counterintuitive, isn't it?
It sure is. It sure is. So why is it so long tonight? Well, it's all to do with the speed that the moon is moving through Earth's shadow. The moon is orbiting Earth, but it's not orbiting in a perfect circle. It's orbiting in an elliptical shape, an oval shape. So sometimes the moon is a bit closer to Earth, and sometimes the moon is a bit further away from Earth. Lots of people are familiar with the term supermoon.
We've got a graphic showing here.
There you go. Yeah. Right. A graphic showing supermoon and micromoon. Sometimes we see the full moon and it looks a little bit bigger than usual, a little bit brighter than usual. That is a supermoon. The moon is slightly closer to the Earth than usual. Sometimes the full moon is a little bit smaller than usual, a little bit dimmer. That is a micromoon, where the moon is a bit further away. This diagram we've got in the corner of our screen, this is a scale diagram showing the relative distances of a supermoon and a micromoon.
So is this one a micromoon then?
So this one, tonight's eclipse, is featuring a micromoon. The moon is further away than usual. One of the things that means is that, as well as looking a bit smaller and a bit dimmer, the moon is also traveling more slowly through its orbit. The closer the moon is to Earth, the faster it travels. The total eclipse we had in May,
that supermoon.
Right, that eclipse featured a supermoon. The moon was unusually close and traveling very quickly through Earth's shadow. That gave us a total eclipse, but a very quick total eclipse because the moon was traveling quicker. Tonight, it's a micro moon. The moon is very close to its furthest point away from Earth. Moon is traveling more slowly, and that is giving us this unusually long eclipse. Just to say those numbers again on how unusual this is. So a partial lunar eclipse where the overall duration is more than 6 hours. The last time it happened was the year 1440. The next time it will happen after tonight will be the year 2669.
It's kind of difficult to grasp.
Right. It's a period of 12 centuries, and this is the only partial lunar eclipse where the overall duration will be longer than 6 hours.
No, that's a lot. But it doesn't feel like it's lasting long. We've got the shadow umbra really eating its way across the moon's surface here, and feels like it's going fast.
It does. The shadow is quickly covering the moon's surface there. The maximum point of the eclipse, where 99.1% of the moon's surface will be covered, that is coming up at 9:02 UTC. So that is in around about an hour and a quarter from now.
Yeah, but even though we say 9:02, these times are a bit soft, fuzzy. All lunar eclipses are quite gradual.
Yes, lunar eclipses unfold in a very relaxed manner. We slowly move from the penumbral phase to the partial phase to the max. So yeah, around about 9 o'clock UTC will be the maximum point of this eclipse.
And we'll be back too in a few minutes. We're going to tell you a bit more about what's happening during this total lunar eclipse. Not total lunar. See? Almost total lunar eclipse. Make sure to check out our live page on timeanddate.live. We've got posts there telling you about the eclipse. We've got posts there telling you about our wonderful partners that are helping us out with all these beautiful images. You can ask questions, you can send your images, and we're also collecting a few tweets and things happening while people are watching the eclipse. So we'll be back soon. welcome back. We're here streaming this partial lunar eclipse over the Pacific and the countries around the Pacific. It is an almost total lunar eclipse. We're going to see 99.1% of the moon's surface covered by Earth's shadow. And Graham, you're going to tell us a little bit about when we're looking at the moon. We see the lighter part of the moon in different places, and you can explain a bit more about that.
Right, so on the screen at the moment, we've got two views of this partial lunar eclipse. Our big main image is coming from San Diego, and in the top right-hand corner, we have a smaller image that is coming from North Bay in northern Ontario. By the way, they are still fighting the clouds. We can see there's that little movement we can see across the surface of the moon. Those are clouds moving across the sky in front of the moon. But when we look at these two images, we can see that the brighter part of the moon is at a slightly different angle. From San Diego, it's sort of pointing slightly up and to the right. North Bay, it's pointing slightly down and to the right. And you may have noticed when we put up some images earlier from some of our other feeds, the moon, the orientation of the moon was looking slightly different. Now there are two reasons for this. First thing we should say is that everybody is watching exactly the same event at the same time. Anyone on the nighttime side of the Earth looking up at the moon sees the same stage of the eclipse, sees the same part of the Earth's shadow covering the same part of the moon's face. But two things that make a difference is the angle that people are looking at the moon. So right now, the moon is somewhere over the Pacific Ocean. It's about halfway between Mexico and Hawaii. So if you're looking at this eclipse from Hawaii, you're looking in one direction towards the moon. If you're looking at this eclipse from Southern California, you're looking at the moon from a different direction. If you're looking at it from the other side of the North American continent from North Bay, again, that's a slightly different direction that you're looking at the moon. And that means that the orientation of the eclipse appears slightly different in the sky.
It's still the same moon.
But it's the same moon and it's the same shadow, and it is the same part of the moon's surface that is being eclipsed. It just looks like it's slightly rotated from different places. One other thing to look out for, and hopefully as this eclipse continues, and hopefully as the clouds start to clear up around the Pacific and North America, we'll be getting more feeds from other telescopes at our streaming locations. Another thing with telescopes is that they do flip the image that we're looking at. Some telescopes flip the image vertically, some flip it back to front. So you can, again, be looking at exactly the same view, but through different telescopes, it comes out the other way round. So occasionally we might see, yes, different orientations of the moon, but it is everybody watching the same eclipse, the same shadow,
same time,
at the same time. That's right. That's right. There is another way of looking at this eclipse. The views here from San Diego and North Bay, these are both telescope images, so we're really zoomed in on the moon. We do have a wider angle view of the sky, and I think we can bring in right here. This is the view from the top of Mauna Kea in Hawaii. And Anna, what are we looking at here?
Well, this is the Subaru telescope. Of course, it's buffering right now, but we're still going to look at it because what we're looking at is the moon being super bright here in the sky, and there's a little kind of cluster of stars next to it, which is actually a very special star cluster that the Subaru gang are really excited about, because this star cluster is called the Pleiades. It's also known as the Seven Sisters, and in Japanese, it's known as Subaru. So it's actually the telescope's namesake. So they're on top of a dormant volcano, 4,200 meters. That's 1,300, 800, 13. Oh, I can't say
I
it.
think it's 13,800
feet above sea level. And our friend Ichi Tanaka there at the Subaru telescope has helped us out with this wonderful wide angle feed of the moon. That's buffering at the moment. Oh, there we're back. You can see the starry sky as well. So it's a beautiful view. And as the moon will get darker, we will probably see that brightness will subside, and maybe we'll be lucky to see a red moon there as well.
Indeed, yeah. This is a beautiful image. We can also just see the domes of the Subaru telescope there. I think I just also saw a shooting star just disappearing behind the telescope there. So yes, this is the eclipse moon, the Pleiades or Subaru star cluster, all thanks to the Subaru Asahi star camera in Hawaii.
And we're going to be back. We were promising earlier that we were going to talk to some of our streamers, and we do have San Diego lined up, and we're going to try and get in touch with them now in your break, not our break. We're going to be busy bees in the background here, getting in touch with San Diego and bringing them to you after when we come back. Make sure you check out our live page, Time and Date Live. You can read more about the eclipse. You can read about our partners. You can ask questions. You can share your images. And we'll be back soon. Welcome back. So we've been busy, busy, busy in the break here talking. We've promised that we're going to talk to San Diego. We've got them on standby at the moment. We're about half an hour, a little bit more away from the maximum of this eclipse, and it's really things happening on the screen here now, Graham. We've got two beautiful feeds going on here, and they look very different. So maybe you want to explain a bit more about that.
So they do, right. So our main image coming from the San Diego Astronomy Association in San Diego, that is Dave and Gary. We're going to be talking to them momentarily. In the corner of our screen, we have our first images tonight from Waimea in Hawaii. Waimea is on the north coast of Hawaii's Big Island. And there we have Preeti Krishnamurthy and Avinash Surendran. These are two postdoc researchers who are working at some of the big telescopes there in Hawaii. And together they do science outreach activity under the name of the Starry Nights.
We've worked with Preeti and Avinash before, haven't we?
This is our second eclipse working with Preeti and Avinash at the Starry Nights, and they are giving us that image in the corner of our screen. Yes, as you said, Anna, looking somewhat different to the view from San Diego. Yeah. We talked before about the different orientations of the moon. We talked about the ways that telescopes can flip the image in different directions. Another difference is the setup of telescopes and the setup of filters and exposures and of all the camera that takes the image from the telescope and feeds it into the computer. So the image that we're seeing from Waimea, this is really emphasizing that the reddish color of the Earth's dark umbral shadow. We can really see that side of the moon really is taking on that reddish tint. The picture we're seeing from San Diego is giving us a beautiful image of the penumbral shadow. That's the lighter part. That's the sort of crescent-ish shape of the moon that we're seeing on the left. Again, it's the same eclipse. It's the same moon. It's the same shadows. It's just different equipment, different
choices
setups
that you make.
Exactly. Yeah. Emphasizing different aspects of this eclipse.
And two of the people that have been helping us so much this eclipse, they've been saving the day with their beautiful images of the moon, are Dave Decker and Gary Hawkins from the San Diego Astronomy Association. And we're going to get them on now and have a bit of a chat with them.
Okay.
Hi there, Dave and Gary. How are you?
We're good. How are you?
Where are you going? Where are you?
We are located about 30 miles east of the city of San Diego in Southern California. We were originally going to do the live stream from my home location, but unfortunately that's being affected by the marine layer. So we've come about an hour 15 miles east. We're actually parked on the side of a highway on a large parking spot here, and the highway leads up to Mount Laguna Observatory. We're about probably about 2 miles away from it. We're about 4,000 feet in elevation, so about 1,350 meters, I guess. And we're outside, as you can tell. It's a good 50 degrees here in Southern California this evening.
Yeah. Wow. It's looking great there. And Gary, we're loving the image of the moon that you're giving us there from San Diego. Just before you came on, we were comparing your image with the image that we've also got on our screen from Waimea in Hawaii. The view from Hawaii is really playing up that reddish tint of the darker side of the moon. Your image is really giving us a beautiful view of that lighter side of the moon. We've been talking about different setups with different telescopes, different equipment. What happens, Gary, when you actually, look up at the moon right now with the naked eye? Is it more like your image in San Diego? Is it closer to the image we're seeing from Waimea? What is it actually looking like in the sky with the naked eye?
Well, actually, it's probably more like the image coming from Hawaii. So the way my camera is set up here at the moment is a full color image, but the exposure is set up, as you said, for the lighter side of the moon, and that's what we're seeing. And the darker side, because of the way the exposure is set up, completely disappears. Now, when I actually look up at the moon, as we're doing now, we can see both the bright and the darker side, and there is a nice reddish hue on the darker side of the moon. Not quite as dramatic as shown in the image from Hawaii, but certainly quite red. And I'm sure if I were to play around with my exposures a bit, I could probably replicate that image, but it is kind of nice to have a contrast between the two ways the eclipse can be viewed.
Absolutely. Yes. Great. And you're there alongside Dave. So Dave and Gary, they're both outreach specialists at the San Diego Astronomy Association. Dave, can you tell us about the kind of work and the kind of activities you're doing in the San Diego community?
Oh, we have a very long and rich history in outreach. Before the COVID break, we were hosting probably 100 to 120 events per year. And we were showing the sky to 10 to 15,000 people each year. Wow. And so we've, it's just a small hand, a small bunch of volunteers that are supporting the effort. And so it's a lot of work. But, those that volunteer to do outreach for astronomy really love doing it. They love sharing the sky. They love bringing the stories about the sky, the history, and helping people of all ages, young people all the way up to the seniors, to understand the sky and appreciate what it is. So we have a very active program. Obviously, like everyone, it was seriously impacted for a couple of years. But as of December, we will have all of our regular monthly public outreach programs back online. So that is 5 or 6 public events per month. And those are open to all the public, and usually in parks or campgrounds. So that's really the heart of what we've been doing. The portion of our outreach program involving schools obviously will not go back online for quite some time. So we're waiting to see if maybe sometime next year we'll be able to get back into some of our schools, elementary schools, the high schools, and so forth, and be on campus teaching astronomy, both in the classroom and in the experiences, stargazing in the evening. So we're hoping to get that going again. In the meantime, though, Gary approached me, a year ago?
Yeah, about a year ago.
About a year ago. And he said, well, we can't do the outreach program like we were, but why don't we try doing some live streaming? And I said, that's a great, wonderful idea, but I have no idea how to do it. But I discovered quickly that Gary does know how to do it. And he's dragged me along into this new technology. And it's been quite a lot of fun. Learning not only the technology, but learning how to speak to people in a virtual way that, most of the younger people are much more tuned into this kind of communication than I am. But it has been a great experience learning how to share the sky, learning how to share ideas through virtual programming and through live streaming. So anyway,
you're doing an amazing job right now.
The what?
You're certainly doing an amazing job right now.
Oh, thank you. Well, it's a challenge. The technology itself is it's somewhat complicated, but there's just a lot of little pieces that can easily go wrong and throw you off base. But for example, up here, we do not have a particularly good internet connection, so we're working off a cellular hotspot and trying to make that handle the bandwidth for all of this streaming. So these are some of the challenges we have in trying to share the sky and participate in your programs as well as many others. But we're having a lot of fun, and we really enjoy and appreciate the opportunity to share our view of this eclipse with time and date.
Well, that's terrific, and thank you so much for the images. With all the clouds we've been having elsewhere, you've certainly saved the day for us so far with your images from San Diego. I have to say it's actually a nice change, because this is the third lunar eclipse that we have streamed with you, and I know it was a very different story 6 months ago in May, when you were there, and you actually had clouds right up until just the very final few minutes of the eclipse, and you just got us there some images right at the end of the event. We're just so happy that
that it's working out for everyone.
Absolutely, indeed, yeah.
So thank you so much, Dave and Gary.
Well,
thank you for your efforts, and we're looking forward to seeing more images from you guys, hoping that you're still above those clouds, and we're going to send people to time and date.
And I would say,
ahead,
if the folks online, do want to pop their heads out the window here, as the brighter side of the moon here gets dimmer and dimmer, the red color that we were talking about earlier is definitely getting much stronger now. So I may actually adjust my image as well in a few moments to see if I can pick some of that up. But definitely worth, if you're close to a window, putting your head outside and taking a look, and then coming back to the live stream for more information.
Yeah.
Thank you. You're doing my job here, Gary. This is awesome. We will be back soon. Pop your head out the window if you know the eclipse. If not, go to timeanddate.live and check out our info there, and we'll see you back soon. Hi and welcome back. I hope everybody took the opportunity of sticking their head out the window and seeing a red moon. We can see that Gary has adjusted his camera and we're looking at an awesome blood moon here. This is why they call it a blood moon, because it goes blood red, and it's quite interesting to look at the moon this way compared to the normal moon, the normal full moon that's white and bright. And you've got this doom and gloom creepiness going on. But we know what's happening. It is the moon moving into Earth's shadow. It's the light bending and refracting and the red light scattering across the moon's surface.
Yes.
And we've got Waimea up there. They're also showing the redness. And we did have New York flying about up there in the right-hand corner of our screen, didn't we, Graham?
We did. So over in New York and also in Northern Ontario, we have our streaming partners there. In New York, we have Kat Troche at the Amateur Astronomers Association. She's on the roof of her apartment building in Queens, in New York. And this is the second time we've worked with Kat. And she had terrible luck the last time. We were working with her for the annular solar eclipse back in June, which was a very big partial sunrise eclipse from New York. She was completely clouded out with that. Tonight, she's up on her roof, and she did catch a fleeting image of the moon, which we did manage to get in the corner of our screen there for a short time. But we are still, fingers crossed, we are still hopeful that the clouds are going to clear up there. Also got to say that in Northern Ontario, we have our teams there working away, fighting the clouds. In North Bay, we've got our team at the North Bay Astronomy Club. We've got Bill Montague, we've got Dave Roscoe, we've got Randy Curry. Again, we're seeing sort of fleeting images of the moon from there. Again, fingers crossed that things are going to improve in North Bay. We also have our team in the nearby city of Sudbury.
120 kilometers away.
That's right. And similar story there, fighting against the clouds. We are hoping to talk very soon to Aletha McIntyre and the team in Sudbury, Northern Ontario. In the meantime, San Diego.
Look at this.
Yeah. Beautiful image there, and a fabulous image coming from the Starry Nights.
We're only like 5 minutes away from the max. We've already said that this is quite gradual. This looks pretty perfect to me. So what can we see once we near max? Now, this isn't a total lunar eclipse. This is almost total. So does that make it any different?
Yeah, so this is more or less the maximum point of the eclipse now. And we can see that nearly all of the moon has turned that reddish color. There is just that little sliver of the moon which is left untouched. And this is as far as this partial lunar eclipse goes. We don't quite get the whole moon covered by the dark umbral shadow of the Earth. There's just that little tiny sliver left uncovered.
It looks awesome, though. It doesn't matter, does it?
No, it looks it looks terrific there. Yes, it's the southern part of the moon which is staying uncovered. You can just see that this is the southern part of the moon. This is where there's that big crater. We can see the Tycho crater, one of the most, probably the most prominent crater on the near side of the moon. So it's that southern edge of the moon is just staying uncovered during the maximum phase of this.
Gary's doing a great job of showing us the detail.
Yeah, absolutely.
Of the moon.
Yes,
So,
yes.
it's awesome. But there's something that we can look for still kind of around now. Do you think we're going to be able to see the turquoise band?
Right. Well, this is always one of the big challenges when we have a lunar eclipse that gets around totality. And we're not quite at totality here, but we are very close to totality, because we've been talking a lot about the red color of a lunar eclipse, and we can see it so clearly on this image here. There is another color that can appear close to totality during a lunar eclipse, and that, as you say, is a turquoise color. You were explaining earlier, Anna, that the Earth's dark shadow has got this reddish tint because the blue is being filtered out by Earth's atmosphere. If we look at the very edge of the Earth's atmosphere, where the ozone layer is, this has a different composition, and this filters light in a different way. The very edge of the Earth's atmosphere actually filters out the red and turns the light a blue turquoise color. So as the moon is moving through that very outer part of the Earth's dark shadow, you can sometimes see a bluish, turquoise-ish band moving across the moon. If you see it, it's normally around when totality begins. So somewhere around now, we may or may...
This isn't totality, right? So you know, we've got...
So we're very close to totality, but we're not quite at totality. It's always a challenge to see the turquoise band.
Have you ever seen one?
I've seen it in photos, but never seen it directly. It is difficult. The conditions have to be really good to see it. We may get a hint of it tonight. In fact, we have a diagram in the top right corner of our screen, which shows us what is happening. In fact, this tells the story of the eclipse so far. Yes. So here we've got this sequence of 4 diagrams which show the Earth's 2 shadows. There's that light grayish outer shadow, the penumbra, and then there's that darker inner reddish shadow, the umbra. And between those 2 shadows in this diagram, we have put that very sort of faint turquoise band around the edge of the umbra. So this eclipse started about 3 hours ago, when the moon began to move into the Earth's penumbra. The partial phase started about an hour and 40 minutes ago, when the edge of the moon first entered the umbral shadow. For the last hour and 40 minutes, the moon has been moving deeper and deeper into that reddish shadow until we get to our final image there, the partial max, really where we are right now. This is the maximum point. Nearly all of the moon inside that reddish shadow, except that little
sliver.
Exactly.
An annoying little sliver, I feel, but I'm trying to focus on this beautiful image of the moon instead, because I just want it to be perfect, right? But there's a number under there, and it says 0.97. We've been saying a lot of 99%, 99%, 99.1%, but this is a different number.
Right. There are 2 ways to measure how deep an eclipse is. The number we've been using, 99.1%, that is the obscuration of the moon. We're talking there about how much of the moon's area is covered by the Earth's dark shadow. And that number is 99.1%. There is another way of measuring how deep an eclipse is, and that is the magnitude. And there, instead of looking at how much of the moon's area is covered by the Earth's shadow, you look at how much of the moon's diameter is covered by the Earth's shadow. And that number, magnitude, is normally given as a decimal fraction. And that comes out at 0.97. So magnitude and obscuration, the two numbers are always
Close.
very similar, but there are slight differences because one is measuring how much of the moon's area is covered, the other, the magnitude, measuring how much of the moon's diameter is covered.
We decided to use the obscuration because it sounds more impressive, and it feels more like an intuitive, easy way to understand how much of the moon is covered, right?
Right. Normally, obscuration traditionally is only quoted for solar eclipses, where it measures the percentage of the solar disk that is covered by the moon. Traditionally, for lunar eclipses, only magnitude is quoted. But as you say, I mean, we think it makes a lot of sense to talk about the percentage of the area that's covered. So at time and date, we also give the obscuration as a percentage.
And we're looking at this beautiful image, and we're officially past max. I didn't see any kind of turquoise band going on.
No.
So this is it. Sounds really bad because it's not, because this is gorgeous.
This is spectacular, but yes, we are now into the second half of this eclipse. Another reminder that this is the longest partial eclipse in a period of 1,200 years, 6 hours and 2 minutes. But yeah, we've passed the midway point. The moon from this point onwards will be starting to get brighter. The dark shadow will start to move off the face of the moon. Again, it's all happening very slowly. This is going to be happening over the course of the next 1 hour and 40 minutes.
And the micromoon is out there. It's flying further out than it normally does. It's flying slowly. It doesn't fly, but it orbits. But same thing. And it's moving along there, and it's moving slowly. And how is this different from the eclipse we had in May, the total eclipse? Because I don't really see that many visual differences. I'm looking at this bright red moon, or rusty red moon, and we were looking at a fairly similar moon in May.
This looks incredibly similar to the total lunar eclipse we saw in May. That was the May total lunar eclipse was only just a lunar eclipse. The magnitude of that eclipse was just a fraction more than 1, which means that the moon just completely moved within the Earth's umbra. Here, the magnitude is just a fraction less than 1. So there's just that little bit of the moon outside the Earth's umbra. But as you said, it looks very similar. The edge of the Earth's shadow is not a very clear, distinct line. This is coming through the Earth's atmosphere, which is a very fuzzy thing. So the edge of the shadow is not a very sharp line. So to say exactly when a partial phase ends and when a total phase begins, it's actually impossible to be completely specific about that. And it's a very fuzzy edge of the shadow that we see on the moon. So the May only just total eclipse and this November almost total lunar eclipse, they do look very much the same.
If you do like Gary and you look up at the sky, you're going to see the same moon, right?
Exactly, yes.
We're going to leave you here and take a little break, but we will be back. We're hoping to talk to Olathe McIntyre in Sudbury at the Science North Centre there. So we need to catch up with her now in the break and figure out how we're going to do this. And but we will be back. And while we're back, check timeanddate.live. You can read more about the eclipse. You can read about Olathe. You can read about Gary. You can read about Dave. You can read about the Starry Nights. You can read about Kat in New York. There's so many lovely people that are working with us on this eclipse. So be sure to check that out and tune in with us soon.
You're watching a partial lunar eclipse on time and date, the longest partial lunar eclipse in over 1,000 years. We can see where we are on the timeline on the left-hand side of our screen. The overall duration is more than 6 hours, and we're just over halfway through that. The maximum point of the eclipse came around about 25 minutes ago. The moon is now being uncovered again. The Earth's dark umbral shadow is slowly moving off the face of the moon. And over the course of the next 1 hour and 20 minutes, it will be slowly uncovering the moon once again. And the moon will be returning from its reddish color we're seeing here. It'll be returning to its traditional silver grayish color. Right now on the screen, we've got two fabulous images of this eclipse. Our main image coming from the San Diego Astronomy Association. That's Dave and Gary up in the hills outside San Diego. And the small image in the top right corner, which just as we look at it,
clouds.
this has been the story of the night so far in
Sudbury.
Northern Ontario,
Yeah.
in Sudbury. We've got streaming locations in Sudbury, in nearby North Bay, also a bit further east in New York. All night.
Struggling with clouds.
Struggling with clouds. We did see there, Anna, we did have a beautiful blood moon in the corner of our screen, but now we just have a black cloud.
And there is probably one person scrambling now thinking, oh, right now, this was the worst moment that the moon could disappear.
Right. This is appalling timing that the clouds have, because we are just about to go live to Sudbury, and we're going to the Science North Museum in Greater Sudbury in Northern Ontario, where we're going to speak to Aletha McIntyre and the team at the Royal Astronomical Society of Canada Sudbury Centre. So, Sudbury, can you hear us?
Loud and clear, Graham.
Hi, you guys. Wow, you're huddled up there in front of the camera. We just, well, Graham just told us where you are, but who are you with, Olathe?
So these are lovely members of the Royal Astronomical Society of Canada Sudbury Centre. So I'll let them say hello.
Hi,
Norm.
Hi, it's Colin here. Paul Velez, same thing.
And Linda Pelaya.
Nice to meet you all.
Excellent. And you all look very wrapped up there. What's the temperature outside there in Sudbury at the moment?
It's about -2 degrees, and we have had snow and rain in addition to all the clouds.
Wow, golly.
And you've
It's a
been
bit windy
fighting those
too.
clouds. Yeah, we could hear the wind earlier. You've been really fighting those clouds, but we can see a sliver of the moon peeking out through the clouds there. We've got your moon right above you. You've got above you in the sky, and we've got it above you on the screen. Yeah. And it sounds like you're having fun.
Oh yeah. We're having fun, yeah.
Oh, yes, we've had fun.
Okay, so you guys so you guys are outside of the Science North Museum there in Sudbury, and Aletha, you're part of the space place at Science North. What's that all about?
Well, actually, we're up here at our Dynamic Earth site, and something fun about Sudbury is that we are actually on the edge of the world's third largest crater, which I think is a really fitting place to be, observing the spectacularly cratered surface of the moon. So we're in a pretty neat location, and we are outside. I can just show you briefly our setups here. So that's my setup. I'm using my Android phone to send the images, the Celestron 11 there. And Norm is over here. Get him there. There it is.
Well done.
Yeah. And then behind me, Colin, so we tried to get 3 different views. So I'm really zoomed in, Norm's kind of mid zoomed in, and Colin has his camera here with a new toy. It's been tracking the moon beautifully all night.
Yeah.
Not that we can see a
Wow.
lot
Okay.
of it. Okay, so now that you know where I am, Space Place is sort of my domain at Science North. I'm a staff scientist there. And I kind of take care of, I actually do take care of a hands-on exhibit area. So you get to come in and really engage with science and the fundamental physics involved in exploring space and understanding our place in the world. And I also run the planetarium. So I actually get to fly through space on the regular, which is very fun.
Yeah, great. And just as you were talking there, I think that was from Colin, just above you on the screen. We had a very nice moon image come in there from Colin, although again, I think it's just getting lost by the clouds. Now, Aletha, over the next few years, there is going to be a lot of attention focused on the moon. Can you tell us what's going to be happening with the moons, with the moon and humans over the coming years?
Well, this is something that I find very exciting. So most of us are absolutely familiar with the Apollo program, which sent men to the moon. And we are now ramping up for a follow-up program that has actually been called Artemis. So Artemis was the twin sister of Apollo, or is, in the pantheon of Greek gods and goddesses. And Artemis is actually the goddess of the moon. So it's really fitting that this program, which is aiming to return humans to the moon, is named Artemis. And especially because this time, it's not just going to be men that go. The goal is to send women and also to send people of color. So that's pretty exciting.
Yeah. And what's the latest time frame we're looking at for this program?
So have been delays. So the hope was to really have it going in 2024. It's definitely already underway. 13 countries have signed on to the Artemis Accord, including Canada. And maybe for those of you out there watching, maybe your country too, look it up, check it out. So it's in progress. We probably won't have people going up by 2024 because we have to design whole new spacesuits that people can work in a gravity environment with on the surface of the moon. So that's a whole new engineering challenge. But near future.
Yeah.
And Aletha, do you actually want to go to the moon?
I would absolutely go to the moon if given the opportunity. And as you know, I did apply to be an astronaut with the Canadian Space Agency. I made it to the top 2%, but I was not selected. The consolation prize is that I am now an ambassador for the Canadian Space Agency, and they actually help fund the live start parties that Science North offers in and also virtual. So it's very fun to still be working with the Canadian Space Agency. I absolutely respect them. They're an amazing organization.
And what did you have to do to get to those final 2%? How do you go so far in becoming an astronaut?
Well, there was a really long application. So nearly 8,000 people started the application and less than 4,000 people finished it. So that weeded out a lot of people right there. But after the lengthy application, there were some online tests and some medical exams. And once we got through those hurdles, there were 72 of us left who actually got to go to a military base in Quebec and go through an assessment. So I was in a group with 24 other candidates, and something that's really awesome is that the 2 candidates who were selected, Josh Kutrick and Jenny Seide, were in my group, and Jenny and I actually buddied up. So I got to know her pretty well. And because Canada is part of the Artemis program, we're building a Canadarm3 to go on the Lunar Gateway, which is the space station that will be in orbit around the moon, and which will also act as the launching point for the Orion vehicle to go on to Mars. Because we're contributing a Canadarm to that, it means that we get to send an astronaut as well. So I don't know if it'll be Jenny, but there's a chance that that someone I know and have met and have spent some really amazing time with, I might get to follow her adventure to the moon.
Wow.
I'm getting kind of jealous of both Aletha and Jenny, I think.
She also wants to come to Science Park too, because she studied combustion in microgravity, and we have this big discovery theater, and we're always blowing stuff up in it. So she really wants to come and blow stuff up in the theater.
Who doesn't want to blow stuff up?
I know, right?
Excellent. Well, that is really something we can all be looking forward to over the coming years. So yeah, Aletha, thank you very much for giving us a very different perspective on the moon there. And yeah, that's going to be great to follow the progress of Jenny and the rest of the Artemis program over the coming years. And Aletha, thank you so much for having a chat with us tonight, and thank you to all the team there for all the work and for all the fighting against the elements and the weather. And we've had our fingers crossed all night that the clouds will clear up a bit.
And they have a little bit.
They sure have. Yes.
We actually had a peak at like a few seconds right at 4:02 at our maximum. We did actually get to glimpse it, which was pretty nice. And we are definitely enjoying exploring space from Earth right here in Sudbury, Ontario.
Well, that's terrific. And hey, Aletha McIntyre at Science North in Sudbury, and to the team there from the Royal Astronomical Society of Canada Sudbury Centre, thanks so much for your feeds and for having a chat with us tonight. That's terrific.
As always, we're taking a break, but we will be back. Go to timeanddate.live, check out our news feed. You can read about Aletha there. You can read about Linda from Sudbury RAS.
Right.
And see you soon. You're watching an almost total lunar eclipse with timedebt.com. And we're looking at this really interesting image of the moon here. It's almost like, I'm calling it the fish tank moon, but it again has to do with exposures and how we decide to look at a lunar eclipse and to expose for the light side to get the more reddish color on the other side, or exposing on the bright side and then getting the other side being really, really dark. And that we are struggling against the clouds, or I'm saying we, but it's our wonderful partners that are struggling against the clouds, pretty much all over at the moment, except for Dave and Gary here in San Diego. And looking at our timeline, we're moving quite far into the partial stage, moving towards the end there, when it's ending in about 45 minutes or so.
About 45 minutes, and yes, the Earth's dark umbral shadow will be completely off the face of the moon. So, we're going to be here for the next hour bringing these live pictures. The moon right now is more or less directly over Hawaii.
Yeah.
And this is a full moon we're looking at.
Yeah.
So it's visible from anywhere on the nighttime side of the Earth. So right now, yes, this is the view, in fact, from the top of Mauna Kea on the big island of Hawaii. And right now we are looking directly upwards at the moon. The moon is more or less directly above Hawaii at this moment. This is the Subaru telescope.
Yeah.
The
Subaru Asahi Star camera.
That's right. So this is a camera that's been set up next to the big telescope, which we can just see in the bottom right corner of the screen. This camera is pointing directly up at the moon, just close to the moon, but just out of picture here. As the moon is moving directly overhead, we do have that star cluster that we were talking about earlier, the Pleiades star cluster, which in Japanese is Subaru. So this big Japanese telescope at the top of Mauna Kea, named after the Pleiades, named Subaru. So this is a very exciting eclipse for the team at the Subaru telescope.
It is, and look at all those stars. It's just like, it's not only the star cluster, which has completely disappeared now, and but it is quite amazing to be looking at this sky. Okay, the image is buffering, and looking at this sky and looking at all those amazing stars going on there. Now, obviously, internet isn't as good on top of a dormant volcano, so we're back further down to sea level in Waimea, Hawaii here.
Right, so here we've just moved to the north. So we're now at the north of Big Island.
Yeah.
We're down at sea level on the coast. Yes, this is Preeti Krishnamurthy and Avinash Surendran, also known as the Starry Nights. And they are streaming this image of the moon from outside their house there in Waimea on the north coast of Hawaii's Big Island.
Yeah, so here we have it. And we're going to talk a little bit about the moon now, Graham, aren't we?
Right, so Aletha got us thinking about the moon in the interview that we did with her just now. It is an exciting period in the moon's history, coming up with the return of humans to the moon.
And we've got quite a few things going on with the moon on our pages.
Right. At Time and Date, we have just started a new section on the planets and on our moon, and we are building up that section of our website, talking about the solar system and the objects.
We do have a thing called the Night Sky Viewer, where you actually could go in and have a look at the moon and the Pleiades next to the moon, because it does show all the different constellations and planets in the sky, doesn't it?
Exactly right. Yeah, the night sky viewer is always a great tool for seeing exactly what the sky looks like in any particular direction at any particular time from your location. And yeah, we know lots of astronomers around the world who find it just a very, very simple and quick reference tool for seeing what time things are going to rise and exactly where they're going to be in the sky.
And usually what they say, then we're looking for sunrise, sunset, we're looking for roughly position, and that's it. They just go in and they do their thing.
Exactly.
But speaking of the moon, we have a fairly special moon, don't we? Except for it's super special right now, but
right. So there are over 200 moons in our solar system. Our moon ranks as the 5th biggest of these moons. Jupiter has 3 moons that are bigger. Saturn's moon, Titan, is also bigger. So in terms of overall size, our moon ranks as number 5.
Out of how many moons?
Out of over 200 moons.
Okay, so it's still quite big.
It is. But what is really special about our moon is its size relative to the size of its parent planet. In other words, the size of the moon relative to the Earth. So the moon is about 27% the size of Earth. And by that measure, the moon is number 1 by a long, long way. In fact, the moon is enormously big. The second biggest moon in the solar system, in terms of size relative to its parent planet, is Triton, a moon of Neptune, and that is 5% the size of its parent planet. So our moon, 27% the size of Earth. In second place, Triton, 5% the size of Neptune. Our moon is, by that measure, just a giant within the solar system.
Neptune's pretty big too, though.
Neptune is much bigger than Earth.
Yeah.
Yes. But Triton, the size of Triton is smaller than the moon, and yes, and certainly relative to the size of Neptune, much, much smaller.
Super interesting. And how did the moon happen? How did it? Because what are moons and how do they happen? And our moon is fairly round and perfect and.
Yeah, so at the moment, the most widely accepted theory for how our moon came to be was going back to the early days of the solar system, when there was a lot of things flying around the sun. There were planets being formed. There was a lot going on. The widely accepted theory is that the early Earth was struck by a large object, a Mars-sized object, and that this collision threw up a lot of debris, which went around the Earth, and over time, gravity pulled this debris together, and it formed the moon that we see today.
Fascinating. Like I just can't. I'm struggling to kind of imagine it, but it, yeah. But then the moon gets bombed away. Those things have been. You're talking about this collision way back when, but the moon has been bombed as well, with stuff flying around, rocks flying around in space.
Right. So that there has been a lot going on in the inner solar system, and the Earth has been bombed a lot as well by meteors and objects flying around. Of course, the big difference between Earth and the moon, firstly, Earth has an atmosphere, so a lot of the things actually getting burned up in the atmosphere before they reach the ground. The other big difference is that Earth is really a living planet. It's got plate tectonics. There's erosion going on. When there is a big impact in the past, and when there are big craters formed, they don't last forever on Earth. They get covered up and hidden away. When we look at the moon, on the other hand, first of all, there's no atmosphere to filter out any of these objects. Plus, there's nothing happening on the moon in terms of plate tectonics or erosion. When there's an impact happening, that crater stays there as a record. So yeah, when we look up at the surface of the moon, we're just seeing the whole history of the solar system in terms of these impact craters that we can see on the moon's surface.
And at the moment, both Waimea, San Diego are exposing for the dark side of the moon, so we can't see these details. I think moving on in the show, we might be able to see some of these craters and some of these details. And you mentioned one on the southern pole of the moon. What was its name again?
Yeah, that's right. So at around about maximum eclipse, where we just had that small sliver of the moon uncovered by the Earth's dark shadow, that was the southern edge of the moon, and that's where there's the very prominent Tycho crater, which is very easy to spot at full moon, and yeah. As you say, the two moons that we're looking at here, we're still seeing that reddish color there. But now more than half of the moon is out of that dark reddish shadow, not out of the shadow altogether, because Earth does project two shadows into space, as well as that dark umbral shadow. There is the lighter penumbral shadow. So that bright half of the moon, it's not completely out the shadow yet. It's still within the penumbra, but that is considerably brighter than the umbra. So yes, if we're wanting to catch that red color that we're seeing here, that means the other side of the moon is looking very bright indeed.
It is. And you can read more about the moon on timeanddate.live. We've got news posts about that, and make sure you check it out. We've got a news feed. You can ask your questions, you can share your images. I went in the break and had a look now and saw these beautiful Twitter images from around the world that are sprinkling their magic moon dust over our live stream news feed there. Oh, look, they've adjusted the exposure, and now we can see the crater. Is this Tycho?
So right now we can see that crater indeed. Yes. And now this is a great contrast now of what we were talking earlier about, the two different ways that you can look at the eclipse. Either you can look at that reddish color on the eclipsed side of the moon, or you can look at that silvery color on the penumbral shadow side of the moon. This is a great contrast here. Same moon, same shadows, the same moment, just different exposures and just bringing out different details.
Read more about it, timeanddate.live. We're going to take a quick break, but we will be back soon, and see you later. You're watching a partial lunar eclipse here with time and date, and we're coming towards the end. The partial phase is ending in about 15 minutes if we're looking at our timeline there on the start. It'll end at 10:47 UTC, around 10:30 UTC. And we've been enjoying some cloud-free images for once from Kat in New York, Kat Troche, and from the Amateur Astronomers Association there in New York. And we've got the San Diego Astronomy Association, Dave and Gary, who we've talked to earlier in the show, who are giving us a beautiful image of the craters on the moon there.
Yeah, we kept on hoping that the weather was going to come good in New York,
and it did.
It's almost the end of the night.
Yeah.
So it's 5:30 in the morning local time in New York. The moon is getting pretty low in the sky there. So it's going to be morning very soon there. But yeah, Kat Troche is she's got a great view from the top of her apartment building in Queens. So she's following the moon as it gets lower in the sky, and finally she's able to give us these great cloud-free images.
Well done, Kat.
Yeah.
You've been working hard. We know all about it. And so we also were looking at some images from Colin there in Sudbury. We had a little message from them that it was starting to snow. They're packing up.
Right.
So it's slowly subsiding the whole eclipse and the excitement. But we're still here, and we'll be here for a little while more because, as you might know, eclipses don't really come alone. And there will be another eclipse in 2 weeks, a solar eclipse. And it's a total solar eclipse that can be seen in the Antarctic. And we're not going to the Antarctic. And the Wi-Fi mobile coverage there is notoriously bad. So it's quite difficult to stream an eclipse from the Antarctic. But we've got a little band-aid, we're going to give you something after all, aren't we, Graham?
Yes. So tonight's lunar eclipse is happening at full moon. We've got this, near perfect alignment of the sun, earth, and moon. In 2 weeks' time, we have a new moon. But this near perfect alignment still holds in 2 weeks' time. This time, the order is going to be sun, moon, earth. It's going to give us a total solar eclipse, but only just.
Yeah.
because the moon's dark shadow is just hitting the bottom of the globe. The path of totality, the area where the moon can be seen completely covering the sun. This is a narrow path that goes across the continent of Antarctica.
And so some people call it a polar solar eclipse, but we've got a bad name, haven't we, Graham?
So we're calling it the penguin eclipse.
Because mostly penguins are going to see it, right?
It is mostly an event for penguins. Alas, we cannot bring live images of this just because of the notoriously bad internet connectivity that there is in Antarctica. So we are going to be running a live blog. We're going to be featuring the events as they happen, just with text and with images.
Like we're doing tonight, but without us blabbing away.
Exactly. And we have been talking to some of the folks down there in Antarctica. We've been talking to people at the Union Glacier Camp, at the Rothera Research Station, at the Troll Research Station. We've been finding out about what they're doing down there in Antarctica. We're going to be sharing this with you on our live blog over the next couple of weeks and keeping you up to date with events. But alas, no live video of the eclipse that happens there.
Unfortunately. But there are more eclipses to come.
There are.
Yeah. Just like tonight, or almost like tonight, there will be a total lunar eclipse in May next year.
That's right. We have 2 total lunar eclipses coming up.
Yeah, another one in November.
In 2022, right? The first one, May 15 to 16, and the second one, 6 months later on November the 8th. Again, these are very much North America, Pacific events. And again, we're going to be streaming these eclipses live on time and date. As far as solar eclipses go, we also had a note there of a big partial solar eclipse that is coming up in 2022. This is on the 25th of October, 2022. This will be a partial solar eclipse across a region that includes sort of part of Eastern Europe and some of Western Asia. And we're hoping to stream live pictures of this big partial eclipse on October 25th.
We're pushing all the clouds away. It's a cloudy time of year. Right. So we've just witnessed it now that this is a cloudy time of year. So yeah, it's super cloudy. So, but awesome people want to work with us and we want to work with awesome people. So if you're in the path of totality of that partial solar eclipse, not path of totality, part of partiality. Is that a thing?
Okay, yeah, the area where the partial eclipse can be seen. Yes,
Get in touch. Huh?
absolutely.
Yeah.
Yeah.
We want to work with new, wonderful people like we have been doing today. So we'll be back in a few minutes. We're almost at the end, but we're not quite. Make sure to check out our live blog, and there's a link in there to the live blog for the solar eclipse. And go to timeanddate.live, read more about this eclipse, about future eclipses, ask questions, share your images, do all the fun stuff, and we'll see you soon.
You're watching a partial lunar eclipse on time and date, and we are very close to the end of tonight's event. If we check in on our timeline on the left-hand side of our screen, this whole eclipse started about 5 hours ago with the start of the penumbral phase. We went through a very long partial phase, and we are now coming up at 10:47 UTC. We are now arriving at the end of the partial phase of this eclipse. Now, there's still about 1 hour of the eclipse to go, but this is the penumbral phase. So Earth has two shadows. It's got that dark umbral shadow in the center, but that's surrounded by a lighter penumbral shadow. So although the moon has now moved out of that dark inner shadow, it's still traveling out of that lighter outer shadow. And it's still going to take more than an hour for the moon to get out of that. But in terms of the spectacle in the sky, we are nearly at the end because the penumbral shadow is very light and very difficult to see on the moon's surface. So we really are nearing the end of the dramatic stage of tonight's eclipse. Once again, this has been the longest partial lunar eclipse in 1200 years. The overall duration, 6 hours and 2 minutes for a partial lunar eclipse. That has been the longest since the 15th century, and it won't happen again until the 27th century. We hope you've enjoyed watching it on time and date. Anna, we need to say a huge thank you to all of the partners we've been working with tonight.
Massive thank you. So I'm going to take it away.
Take it away.
Take it away. In Hawaii, Preeti Krishnamurti and Avinash Surendran from the Starry Nights, Olivier Guillon at Project Panaptis, Ichi Tanaka at the Subaru Telescope, all of them on the Big Island in Hawaii. In Southern California, Gary Hawkins and Dave Decker from the San Diego Astronomy Association. We talked to them. They looked up at the moon. It was exciting. It was exciting. In Ontario, Canada, we've got Olathe McIntyre at Science North. We talked to her as well. And Linda Pullier, Colin DeRocha, Norman Hay from the Royal Astronomical Society of Canada. They huddled up behind her and said hi, and they were all very excited. 120 kilometers to the east. We've got North Bay Astronomy Club. They're in North Bay. It's Bill Montague. It's Dave Roscoe. It's Randy Curry. And last but not least, in Queens, New York, on the top of her apartment building, we have Kat Troche from the Amateur Astronomy Association.
Well done.
Thank you. Thank you so much, everyone. And I think we've seen a little bit of something from pretty much everyone. So very excited that everybody got a little bit of clear sky going. As always, we have our news feed. It's going to be hanging around. We'll be gone, but that will be hanging around. You can go in there, you can read, you can click. We're going to leave you with some resources at timeanddate.com. All kinds of fun stuff to do. Our planet pages, the moon pages that we're talking about, the night sky viewer, meteor shower map, eclipse animations, planet tools, sun and moon calculator, cosmic calendar. We've got so much fun stuff in there, and it's all listed on the news feed. And we're excited because we're going to be showing you a total solar eclipse in 2 weeks. We're at least telling you about it on our live blog in 2 weeks. So we can almost say, see you in 2 weeks.
Yes.
Thank you, Graham.
Excellent. Thank you.
Thank you, everyone. Bye.